Hello everyone. Our topic today is architectural drawings. We'll talk about the use of orthographic drawings in architecture and then go into some specifics of the particular types of drawings. Floor plans, including some of their elements, elevations, interior elevations, and sections. So you've learned about orthographic drawings and the glass box technique for three-dimensional forms. In architecture, we use the exact same technique for our buildings. And so you can see on the left the three-dimensional form of a typical house. And on the right, if we took that glass box view and unfolded it, you can see the different views and drawings that come from that. So let's start with the most common of those architectural drawings, and that is a floor plan. A floor plan is an orthographic view. All right, it is straight on 90 degrees, no angle, no foreshortening of a particular building or an area, and it's constructed or seen as if there were a horizontal cutting plane passed through the building, and the height is usually about 4 feet, 4.5 feet above the floor line. And that's pretty standard so that you cut through all of the doors and windows, but miss things like countertops. All right. And just to hit this one more time, the viewer is looking straight down. It is orthographic 90 degrees into the building. Floor plans are drawn to scale, and they are detailed to show the walls, doors, windows, plumbing fixtures, appliances, stairs, cabinets, etc., etc. On a floor plan, different symbols and line weights and types of lines convey information. So let's take a second look. On the left is the illustration of the three-dimensional house with the knife slice through it. On the right, you can see the finished floor plan as it was drawn. All right, so even though the drawing on the left shows the depth of the house, the drawing on the right, the floor plan does not show any depth. All right, it is a two-dimensional drawing. Let's talk about doors next. Doors in a plan view are drawn in an open position and they show the direction of operation. Let's take a look at this example. We have a door right here. You can see that this rectangle, this slim rectangle, is the actual physical panel of the door. This arc represents the swing of the door as it moves. So you can see that it's shown drawn in its open position. The hinge point would be right here, and the latch point would be right here. There's many different types of doors, and here are some of the most common examples. Take a look at the top left. This is your typical single swinging door we just talked about in the last slide. So here is the door panel itself. Here is the hinge side. Here's the latch side. It's shown in the open position and with an arc drawn for that door swing. Some other common ones you might come across is a sliding door right here, a pocket door, or a folding door like a bifold closet door. Let's move on to windows. The operation, or how windows are opened, is more difficult to describe in a floor plan view, so they're usually shown in the closed position, and they're drawn simplistically. Sometimes the size and operation, the type of window is noted on the plan. If you look at this example, they've got a note next to each window, right here, right here, right here. All right. Or sometimes they are tagged with a number or a letter and then listed in a window schedule. So really typically a window is shown, here is the wall next to it, as kind of an open wall. So it's got two lines representing the sill and then a center line that is representing the glass that you're cut through. So very simple, 3 lines for the window. Now this happens to have a pochade wall or a filled in wall. If this were an open wall, you'd also see that there's a line here and a line here for the jamb, the sides of the window. Now this is going a little deeper than we maybe need to in this course, but I wanted to show you that there are many different types of window. You can take a look and see the different type, for example, a fixed window, what it looks like in elevation, and what it looks like in plan when you cut through it. Now, when you look at these examples, you'll see that we don't see in these plan views the lines for the window sill when you cut through and look down. In this case, the artist, whoever drew this, is showing the window itself in isolation. All right, that's it for floor plans for today. Let's move on to elevations. An elevation is a scaled and orthographic drawing also, and it shows a vertical surface or plane. And it's typically seen from a point of view perpendicular to that picture plane, that sheet of glass that's outside of the building. Why do we need elevations? Well, elevations are going to show heights, materials, other information that you really can't show or can't be seen on floor plans or other drawings. For example, take a look at this elevation and look at the trim detail up here near the top of the building. There is really no way to show that trim detail in a floor plan view. So you can see how important the elevation is in this project. One thing to keep in mind when you're drawing elevations on a sheet for a project, if you're drawing multiple of them, for example, north, south, east, west elevations, align the grade line or ground line. That's this one, right? So that all of your elevations line up. So those were exterior elevations, but we can also have interior elevations. And these are drawings that illustrate the finished appearance of an interior wall of a building. And here's an example. If you, the observer, were standing right here in the middle of this room looking at this kitchen wall, this is what you would see. You'd see to the left the edge of the wall, and then this doorway, and then we'd see the length of cabinets, and then we'd see the window to the right. And so you can see that this interior elevation shows that wall. There's one more really common drawing type, and that is sections. Section drawings are going to take an imaginary vertical slice through a building. All right, so when we did a floor plan, it was a horizontal slice. Now we're going to slice vertically through a building. And draw a section to give information on heights and relationships between the floors, ceilings, interior spaces. Sections are used at different scales. For example, on the right, we have a section through an entire building. All right, you can see the different rooms. And we drew this in order to see the relationship between these structures here and the interior spaces. On the right, we see a section drawn at a much larger scale that is cutting through a cabinet. This is a millwork detail, and it's shown how that cabinet is put together and constructed. Thanks, everyone. That was a quick run through of the common types of architectural drawings.